Alright, okay. So I had my tutorial. Well, it started like 3 minutes ago, and she confirmed that all we're going to be doing is setting up the IDE Eclipse and installing Java. But I already have all that done, so instead of wasting my time there, I knew that it was going to be just a useless throwaway tutorial, at least for the first week. Keep in mind, tutorials aren't mandatory because they post the questions online, so only if you really need help. I don't think I'm going to be attending them too often, if at all, unless problems posted online are really giving me a hard time. But I don't see myself attending these anymore. Uh, the like the questions are going to be posted in 2 days, at least for week number two. However, like I said, tonight I'm going to be streaming my two homework questions. And so everything's set up. You could see me, and you could also see my Eclipse IDE. And so my two questions, let's go. Let's just start up a new project file. Uh, new, wait, new, new Java project? Yeah, new Java project. We're gonna call this one lesson 2 because uh, it's easier for me to keep track. Uh, Everything seems fine. Yep. All right, so that made a new folder here. I'm not too sure if you could see. Uh, that gets bigger, but does this get bigger? No. Well, uh, oh well. Then in my source, I have no classes, so I could even close this if this is from my other one. So let's make a new class. So you right click this, new class. I'm gonna call this class uh honestly I don't know. Question one sounds like a terrible class name, but I'm just gonna write console input one. Uh because that's the question, and I don't know what else to call it. Anyway, so as you can see by default, we have java.lang as the default package, and right, console input one. All right. Oh, I could have added the. Well, anyways, it'll give me some practice. So it's public static void. This is something that you could add auto like on its own. You could tell the IDE to add it for you if you want. But I guess it's good practice to do it on your own, so you don't forget. So public static void main class of string, but it's going to be an array of strings and args, and oh yeah, you gotta do it like this. Even I think this is like supposed to be like this, like my school wants. All right, and just to see make sure that it works, I'm just gonna system.out.println or just print. Uh, Hello, Eric. And if I run this, yeah, okay, so we're good to go. So the first question is, just gonna copy paste it. Oh, obviously it's not gonna do it. All right, so I'll just read it out loud. The video game arcade machines at your local arcade output coupons according to how well you play the game. You can redeem 10 coupons for a candy bar or 3 coupons for a gumball. So, I should probably write it here. All right, so candy bar. So it's 10 coupons for one candy bar, and it's 3 coupons equals one gumball. Um, Next, you prefer candy bars to gumballs, alright? So preference over candy bars. Candy bar preference. Write a program that defines a variable initially assigned to the number of coupons you win. Alright, I might upgrade that just a little bit. Next, the program should output how many candy bars and gumballs you can get if you spend all your coupons on candy bars first, because you prefer them, obviously, and any remaining coupons on gumballs. Right, okay. So we're still early on in this course, so we haven't technically learned how to use the user input. We could only output to the console. But since I know how to do that, I'm gonna actually go ahead and do it. So I know right offhand we're gonna have to import some libraries from Java. So for this to accept the user input, we have to use the scanner, and that you could get it from Java util .scanner. But I prefer importing the entire thing. Doesn't make a difference. The star just says like anything after. Import it, which would include the scanner, right? So inside here, I'm gonna delete this. We no longer need this little test case, and we're gonna create a new variable of class scanner, name it scanner for simplicity's sake, and create a new scanner. And the argument that I was taught to put inside here is system.out. Cool. Now we. Oh yeah, what's wrong here? Huh? But why? Hmm. Well, pretty sure system. Yeah, that's not it. Let's undo that. Maybe I do have to do this? The method scanner print stream is undefined for the type console input. Pretty sure if I do it in this one, it's gonna work. So let's just try it. Let's open up Hello World. And if I import java.util, and if I do scanner equals new scanner system dot. Oh, well, I'm a dummy. Uh, Let me close Hello World. Let's go back here. It's not system.out, system.in. Uh, you have to, right? No? Oh, come on. Alright, let's jump back into here. Alright, let's re-import java.util. Sure, let's put the asterisk. And scanner equals new scanner system.in. That's okay. Why is that okay? Let's copy paste this. Put back the asterisk here. And maybe I'm not doing something. Alright, cool. We're in business now. Uh, don't say for hello world, let's say for this. Right now, the only error is that we don't have, that we're not using the variable, but that's fine. We're gonna use it now. So we're gonna add int ticket total, or ticket count equals scanner dot next. It's not gonna autofill for me. Come on. All right. Well, thankfully I know what to do here. So what this is going to do is it's going to basically read the console that when we run our program, we're gonna have to input how many tickets we have. So in fact, we could even do uh, system.out.println, and we could say inside here, yo, how many tickets you got? And if we run this, it's going to ask us oh, I spelled something wrong. Yep, there you go. All right. You know how many tickets you got? And now it's waiting for us to write a number. And then when it's write a number, it's going to exit the program because there's nothing else for it to do. But that number was actually stored into this variable called ticket count with the scanner.nextInt. Basically, scanner is this variable, and nextInt basically gathers the next integer that is inputted into the console. So now that we have that there, our thing is that with this number, so this evaluates to 21, let's say, we could start doing our arithmetic to get how many candy bars we could get, and then the remainder, how many gumballs we could get. Since this guy prefers, well, actually, according to the question, it's us, so we prefer candy bars over gumballs, which actually is the case. But 10 coupons for candy bars sounds a bit steep. Anyways, so then what we could do is int candy bars, and this would be ticket. Oh, okay. Mm-hmm. All right, so ticket count, which would be, let's say 20. We'll try that out. Divide by 10. Because it's 10 tickets for a candy bar. And then that would automatically in Java, I think, like forget about any decimal points. So because it's an integer, so it doesn't really have access to a decimal place. So it'll just round down kind of, and then the remainder of that, what we could do is int for the gumballs is gumballs equals it would be in this case we would take the original number for ticket count since we didn't really change it, and then we could subtract how many we have candy bars that we yeah, candy bars times 10 because it's 10 coupons for every candy bar, and then we would um, take all this and divided by 3, right? Now, I think there's some unnecessary parentheses here, but at the same time, I don't think so, because if I don't, this would multiply first, and then division is the priority. So yeah, I technically do. Although I think this would work too without, there you go. So parentheses takes precedence, then multiplication takes precedence afterwards, then all this would get evaluated, and then you can divide it by 3. There you go, that's cleaner. And then what we could do is system.out.println. Is it gonna show up on the top of the list? No. Ah, there goes my suggestions. I hate when they go away like that. Alright, so candy bars, and then we could do candy bars. And I wonder if there's a shortcut to duplicate. Nope, I don't know what I did there. I tried to, oh, I just deleted, okay, well, let's do that instead. There you go. And this would be gumballs. And then this would be gumballs. To tally up our stuff. So now, if I run this, I'm gonna write 20. So it should say when I press enter, candy bars 2 and gumballs 0. That's amazing. All right. Now, if we have, let's run the program again. If we say 23 and I press enter, it should be 2 candy bars and 1 gumball. Perfect. Let's run the program again. And I'm curious, so 23 would give 2 candy bars and 1 gumball because it's a perfect amount of number. But what if I have 22? I would only have enough for 2 candy bars and I would be 1 coupon short for a gumball. So it should say 20 when I press 22. Perfect, okay. And let's just try 24, which is 1 more. So it should be still 2 candy bars and 1 gumball. So 24, yes. And now let's try 26. It should be 2. Okay, I think I did it. All right. So that solves it. What here? Scanner is never closed. I never closed my scanners. Don't know how to do that, but okay. Radio. Let's click on show answer to see what I got. Oh, this is how you write good comments. So I'm gonna just copy paste this so that I have something to look for. Look at, so here was the actual question. Kendrick Lamar made it. It's the same question that I basically read out loud, but it's written here. Perfect. Okay, cool. And let's see how they did it. We have 108, change variable as desired. Num. Oh, that would have done it. Yeah, okay. Right, okay. So they did something kind of cool, which I should have thought of too, is that they did this, basically, they divided by 10. But then for the gumballs, we don't need to do like like backtrack to get how many candy bar tickets we initially had or whatever. What we could do is um that's what they did, right? Uh yeah. So what they did here is that they did ticket count modulus 10. And what that does is basically it takes the ticket count, which would be 20, let's say. It divides it by 10. So 20 divided by 10 is 2. And there's no remainder. So it'd be 0 divided by 3, which is 0, right? uh, let's quickly find out. Because I might have forgotten. Is it? I'm pretty sure it's 0. Or is it 1? Is it one of those like weird things? Let's just try 20. It is 0. Okay, yeah. Alright. So you see, that's cleaner. And now we pretty much have the same thing. So this was just a quick optimization. Uh, for next stream, I'm not gonna record my screen. I'm gonna record. Sorry, I'm not gonna record a tab. I'm gonna record the entire screen so that I could click and drag windows into the viewport. Because right now it's not set up that way, so I don't want to mess around with OBS right now. So you'll take my word for it that I'm looking at this at their solution, and it's pretty much identical to what I have, if not a lot lengthier, because they didn't have the scanner. They hard coded values in. But if we run our tests now and redo everything, like how many tickets you got, if I do 20, it'll be 2-0, perfect. If I do 23, it's gonna be 2-1. If I do 26, it's gonna be 2-2. And if I do 24, it's still gonna be 2-1. And if I do 22, it's gonna be 2-0. There you go. Okay, that's good. Done. Question 1 done. All right. So let's create a new class, I would say. Uh, does it automatically go inside here? I wonder. Source, new class, console, input, number 2. Uh, finish. Well, shit. I don't know which one is which. I don't know which one it's supposed to be. Pretty sure I don't need this one. Alright, so let's delete it and delete file. Okay. Oh shit, I did need it. Alright, so let me go back to source. And hopefully it knows what to do when I do console input 2. Finish. Fuck. I don't know if it's supposed to be there. I don't know which one to use. Do I use this one? Do I use this one? Which one do I use? Well, I don't feel like rewriting that whole thing, so let me just copy paste this, all this. Let's do it here, which would be the outside one, which I don't think is the right one, but whatever. And let's see when we run this. Okay, seems to work. It's on the outside. All right, cool. So let's just quickly do this one. Scientists estimate that roughly 10 grams of caffeine consumed at one time is a lethal overdose. Write a program with a variable that holds the number of milligrams of caffeine in a drink and outputs how many drinks it takes to kill a person. Wow, okay. A 12-ounce can of cola has approximately 34 milligrams of caffeine, while a 16-ounce cup of coffee has approximately 160 milligrams of caffeine. Scientists estimate that roughly 10 grams of caffeine consumed at one time is a lethal overdose. Write a program with a variable that holds the number of milligrams of caffeine in a drink and outputs how many drinks it takes to kill a person. Right. Okay. Okay, cool. So, pretty similar to what we did before. How many milligrams of, how do you spell caffeine again? F-F-E-I-N-E in drink. So we're gonna get a number from them. And then what we could do is, I'm pretty sure it's 1,000 milligrams in one gram. Was it gram? Was it again? Yeah, gram. Okay. I'm pretty sure. Yeah. Milligram to gram. Just good old Google. So 1,000 milli. Oh, yeah, 1,000. Milli. All right. That's yeah. I'm glad the public gets to watch me think out loud. All right. So what we could do is then we could do is int uh per cup whatever equals scanner dot next int. There we go. That's the one I want. Yeah. Then what we could do is we know that it takes 34 milligrams, no, 10 grams to kill someone. Jesus, that's so fucking dark. Why did they even say that here? 10 grams kills a guy. All right. So what we could do now is once we have the amount per cup, milligrams per cup, what we could do is we could take 1,000, right? So int cup total would equal to 1,000 divided by mg per cup. Now, thing is, I think we're gonna have to add something extra because this will just give us like the cutting point. Like basically like bare minimum, I think. Right. Well, um let's give it a whirl. Uh system.out.print line, why not? Boom. This amount of cups will, I don't want to say kill, so knock. This amount of sleepy time. Sleepy time. And then we'll put the cup total variable that holds our int, and then cups, just so that's really clear. Okay, let's get this a shot. So, how many milligrams of caffeine in a drink? If I say 10, it would take 100 to kill me, right? 100 cups. Cool. Now the thing is that that's a clean number. So I'm having a hard time thinking in my head without writing it down, but what if it's not a clean number? For example, what if it's like, is 1,000 divided by 160 something? Let's get up my calculator up in this. Whoa, baby. That's a big calculator. Alright, so make it smaller. 160 divided by. Whoa, what am I doing? It would be 1,000. 1,000 divided by 160? Okay, 6.25. So it's not easily divisible by 160. So, how many milligrams of caffeine in a drink? If I do 160, gives me 6 cups. If I do 6 times 160, is it over 1,000? See, it's not. So I would be safe. So I have to add. Oh my god. Let's reread the question. Scientists estimate that roughly 10 grams of caffeine consumed at one time is a lengthy overdose. Is a lethal overdose. Write a program with a variable that holds the number of milligrams of caffeine in a drink and outputs how many drinks it takes to kill a person. A 12-ounce can of cola has approximately 34 grams of caffeine, while a 16 is 160 grams of caffeine. Right. Oh no, but it's 10 grams, not 1,000 grams. So actually, it would be. Uh, let's make an integer int. Lethal dose would equal to 10,000, and then here we would lethal dose divided by milligrams per cup. But then again, we're not in. Uh, I feel like we need a way to say it. Like if there's a remainder, um, go up, round up. Is there a round up? Round up. That would always work in our favor. It would always give you that extra one, and if it's a clean integer, then there's nothing to round up to. Yeah, I think that's the cleaner solution. All right, so I think I don't need to import the library for math. Math dot I guess ceiling. Oh my god. Math dot ceiling. Math dot seal, right? Returns the smallest double. Oh, it's a double. Why is it a double? All right. It could be a double because it's an int. So okay, that is greater than or equal to the argument and is equal to a mathematical integer. Special cases. All right. I think this is what we wanted it to do. I'm just gonna have to convert this into double so that we could use mat.seal because it accepts only wait. It has to be a double inside here. Does that mean that all my variables have to be doubles? Well, let's test it out. All right, cool. So how many milligrams of caffeine in a drink? Let's go back to our trusty 160, and then it says 62. So 62 times 160 doesn't reach 10,000. So that didn't work. So maybe if I make this a double, like that. Now if I run this, 62. Oh wait, yeah, I put the wrong input. 160? 63. See, now it works. Okay. So I did have to make one of the variables a double, which would then force this entire expression to become a double, since milligrams per cup is an integer, and I'd rather not have the user write 160.0. I'd rather him just write 160 as a full integer. Although there could be like milligrams. There could be like point milligrams and stuff. And that would be better than having explicitly saying the lethal dose is zero point 0 because we know that it's always a clean number. Okay, let's try that. And I'm curious to see. Okay, so let me just validate that 63 works. So 63 times 160 would give us overdose. Okay, cool. So let's bring this back. Let's bring this back to an int. Remove this. We don't need it no more. Now let's make this a double. But then if we make that a double, we can't use next int anymore. We're gonna have to do next double. Thing is, they're gonna have to actually write now. Well, let's just try it out. Let's press 160 without doing dot 0. Oh, okay, it still works. It converts it for me. Alright, I'm good with that. Yeah, I'm good with that. Yeah! Alright, let's just try it one more time with a clean number. So 100 would give us another 100 in this case? Yeah. Well, we don't need to have it the point 0 there, do we? Was that the case for the 162? 160? It did give us a decimal. Okay. Um. Well, this would give us. This would evaluate to an integer, wouldn't it? Returns the smallest double value. Really? Returns a double. Turns the floating point value that is greater than or equal to the argument. But if it's the ceiling, then it's always going to be a full integer. I'm curious. What if I just say I want an int actually? Yeah, it gets mad. I could cast it. Let's cast it as an int. Okay. Now, I think we're fully optimized here. Because they could do 160 and it'll spit out 63 cups. That's perfect. And they could also do something like, ooh, my consumption is 160.5. And that would give us 63 cups still, which would make sense. What if I do like a 40.50, 65, let's say. Let's see if that works. So 247 on my calculator. You don't see it right now, but I'll fix that for next stream. 247, 40. Right. Right, because so actually 247 times 40.65 equals 10,040. 55. So 1 cup less. So if this was 246, we would not reach 10,000, which then would not be a lethal dose. So I think this is the best. This is the best I could do. It's clean. Yep, I like it. I'm calling it quits. So show answer for question 2. Let's copy their thingy here. So they do it there. There you go. Okay. Lethal dose is 10,000. And here they did int milligram caffeine per drink 160, which is hard coded, but with us we have a scanner. Milligram fatal, they did 10 times 1000. I just straight up did 10,000 because that's what it is. Then they did int drinks fatal equals mg fatal divided by make caffeine per drink. Oh, they didn't take it all the way. They just divided it and called it a day. Um, yeah, that's not good. I went a step further, not only with the scanner, but also with the more precise way to do it. So yeah, that's it. That's done. All right. This was longer than I thought it would take. I don't know if it's because I was talking out loud or being like in teacher mode, but this is it. So I'm calling it quits, and thank you for tagging along, doing my homework. Bye bye.